there's some angle y, and when we take the sine of this angle, we get x. Okay, and so that means arcsine of x equals y. So y is an angle. Okay, y is some angle. And when we take the sine of x, we get out y. Okay, so I know that's a little bit hard to wrap your brain around, but let's draw this as a triangle and see if we can figure out. So here I have this triangle, and this is the angle y. And when I take the sine of this angle, I get out x. That's what arcsine x means when I take the sine of this angle. And sine, remember, is opposite over hypotenuse, so that means opposite over hypotenuse. X over 1 would give me sine of x, right? Okay, so if I have this triangle, can I find the third side? Of course I can. With the Pythagorean theorem, I find that it's 1 minus x squared, or the square root of 1 minus x squared. So then the question is, what is the cosine of this angle? Well, the cosine of this angle would be adjacent over hypotenuse, right? Which is 1 minus x squared, square root of 1 minus x squared over 1. So cosine of this angle is this mess. Okay, so the reason we're doing this is because we're trying to find the derivative of arcsine, and we're going to use that to we're going to use this information to find that. Okay, so arcsine, we can rewrite this, right? If I said arcsine of x equals y, I could rewrite that as sine of y equals x, because, you know, there's a couple things you could just think about the fact that it's an inverse and we could just switch them around, or we could just say we took the sine of both sides, right? Those cancel out and I end up with sine of y equals x. Okay, so hopefully you feel good about that. So here I have sine of y equals x. Now let's take the derivative of both sides. Since y is not by itself, it has to be implicit differentiation, because we have a function of y, or a function of x inside of another function. So we're going to take the derivative. What is the derivative of sine? Well, the derivative of sine is cosine. And then I have to multiply that by the derivative of the inside times y prime. And what's the derivative of x with respect to x? Well, it's 1. Now, I know what cosine of y is, right? I just found cosine of y, didn't I? So that is square root of 1 minus x squared. So I get the square root of 1 minus x squared times, I'm just going to say dy dx equals 1. Okay, and now I need to find the derivative, and so that means I have to get dy dx by itself because this is implicit differentiation. So I divide both sides by the square root of 1 minus x squared. And I get that dy dx equals, drum roll please, 1 over the square root of 1 minus x squared. So the derivative of the inverse sine is 1 over square root of 1 minus x squared. And it's really odd looking, and it's always just a little bit complicated to think about, but it is. And it's actually really, really helpful in differentiation or in integration, because there are so many times when we end up with something in this form, and we're not going to be doing trig substitutions here much in AB calculus, but we this is actually a really helpful thing to have. Okay, so you're just gonna have to memorize these 3 on the left. These are our derivatives of our inverse function. So you see where they came from, but really you just have to memorize that. Okay, memorize those 3. And remember that the derivative of cosine is negative sine, and so that same pattern holds here. If you look, the derivative of cosine is -1 of the same thing that sine is, just with a negative sign. So that's sometimes helpful. You really don't have to memorize as much as you'd think. So we're going to do the derivatives. Oh yeah, the stuff on the right, again, you can memorize this if you really wanted to, but really it's just the chain rule. So if you understand how to do the chain rule, you don't need to memorize this stuff. And I would suggest against trying to like memorize every last little thing you need. Okay, so we're finding the derivative of arctan. So this is a function inside of a function, right? This is the peanut, and this is the chocolate of our peanut M&M. So we're going to take the derivative of the outside with the inside still intact. So what is the derivative of arctan, well, we have that memorized now in the last 30 seconds, right? Okay, just kidding. We're using our notes, right? You can see I'm using my notes. That's okay. So the derivative of tangent is 1 over 1 plus x squared, but we're going to remember we got to keep that peanut still intact. So this is 1 over 1 plus, and then the peanut stays intact for x squared, okay, times the derivative of the inside, which is just 2, because we're taking the derivative with respect to y. So that's it. I mean, you could put the 2 on top. It probably would look a lot prettier, right? But you don't have to because it's calculus. All right, so we're going to take the derivative of the outside with the inside still intact, and then we're going to take the derivative of the inside. So what's the derivative of arcsine? Well, we just found that. It's 1 over the square root of 1 minus x squared. So we take the square root of x squared because we got to keep that peanut. That peanut has to stay intact inside of our peanut M&M, and then we multiply this by the derivative of the inside. What's the derivative of x? The square root of x. So that's the same as x to the 1/2, right? So this is 1/2 x to the negative 1/2. So again, we could just leave it like this if you wanted to put it on the top, or if you wanted to, bring the x to the 1/2 to the bottom, so you would end up with 1 over 2 root x square root of 1 minus x. Yeah, yeah, that's it. Okay, that really is it. I was like, I think that's what I got before, but yeah, so that's it. That's simplified if you really want to, but you don't have to. Okay, arc cosine. So what is the derivative of arc cosine? Well, so the derivative of the outside is negative 1 over the square root of 1 minus x squared. And the derivative of the inside, well, the derivative of ln of t, this is our peanut. Take the derivative of ln of t, it's 1 over t. Oh, but see, this is an x squared, right? You caught that, I know you did. That's ln of t. We keep our peanut still intact, so we just square it. And that's it. That's inverse trig function derivatives. Okay, I can't say it, but that's what they are.